Funding for this video is made by the Department of Education RISE grants. Hello, Nandima Ture is here again continuing the video on logarithmic function. As you recall, the first video defined logarithm and explained about its use and purpose. In this video, we will explain how to convert exponential function into logarithmic function. Let's go back to the definition of logarithm. It says, suppose a is greater than 0 and a does not equal to 1. There is a number x such that log base a of y equal to x if and only if a to the x equal to y. You must note that logarithmic function is the inverse of exponential function. So if you do not quite understand exponential function, I would advise you to read your textbook and watch more lectures on exponential function before continuing on logarithmic function. Let's do an example of logarithm. We have 4 times 4 times 4 times 4 times 4 equal to 1024. How do we convert this example into exponential form and logarithmic form? Well, let's look at it. We have 4 multiplied by itself how many times? 1, 2, 3, 4, 5. So 4 is being multiplied by itself 5 times to get an answer of 1024. In exponential form, we will write it as 4 raised to the 5th equal to 1024. Where does the 5 come from, you ask? Well, we're taking the 4 and multiply it by itself 5 times, as you see. So it gives us 1024. In the logarithmic form, we will say log base 4 of 1024 equal to 5. As you see in logarithmic form, the 5 is what we want, the exponents. You must remember the names of the different parts of this notation. We have the exponent, which is our 5. We're taking the number, multiplying it by itself 5 times. So the exponent is 5. We have the base. The base is the number which we're multiplying by itself. So in this case, the base is 4. And we have the argument. The argument is the answer you're going to get when you multiply 4 by itself 5 times, which would be 1024 in this case. It is very important that you are able to convert an equation from exponential form into logarithmic form. So let's get started. Write 4 cubed equal to 64 in logarithmic form. Let's go back to the definition. It says a to the x equal to y. If a to the x equal to y, then log base a of y equal to x. So what is our a? Our a is our 4. So 4 cubed equal to 64 implies that log base, well, what is our base? Our base is 4. So log base 4 of, the argument is 64, is equal to, what's the exponent? The exponent is 3. So log base 4 of 64 equal to 3. Let's do another example. Write 5 to the negative 1 equal to 1 over 5 in logarithmic form. Recall the rule of exponents. You have 5 raised to the negative 1. Well, if you recall the rule of exponent, it says a to the negative n is equal to 1 over a to the positive n. So that's why 5 to the negative 1 equal to 1 over 5 to the first power, which is 5. So how do we convert this into logarithmic form? Go back to the formula, which says if a to the x equal to y, then log base a of y equal to x. Our a, as you see, is the 5. Our y is the 1/5, and our x is the -1. So we will write log base 5. And it's always nice to write the base a little bit underneath the log function so it doesn't look as if it's multiplication. So log base 5 of the answer we got in the exponential form, which is our argument, 1/5, is equal to the exponent, which is -1. Let's do another example. 7 to the 0 power is equal to 1. Again, recall the rules of exponents. It says a to the 0 equal to 1, given that a does not equal to 0. So it makes sense that 7 to the 0 power equal to 1, because 7 is not 0. So how do we convert this into logarithmic form? Go back to the formula that says if a to the x equal to y, then log base a of y equal to x. So we have 7 raised to the 0 power equal to 1 will imply that log base, well, what is our base? Our base is 7. Log base 7 of the argument 1 equal to the exponent, which is 0. Let's do another example. 10 raised to the 5th power is equal to 100,000. This example is really nice. I like it. Let's go into the formula. It says if a to the x is equal to y, then log base a of y equal to x. It is highly important that you remember this formula. So we have 10 raised to the 5th power equal to 100,000 will imply that, well, it will say log base, well, what's our base? Our base is 10 of 5 equal to, oh, that's a mistake. It should be log base 10 of our arguments, right? That's a mistake students make, so I want you to recognize that. So log base 10 of the arguments, the argument is 100,000. So log base 10 of 100,000 equal to, now the exponent, and which is 5. You can write this in a simpler form. You need to note that whenever you have log base a, which will be, in this case, log base 10 of a, it's the same as log of a. You say to yourself, how is that possible? It's called the common base. Whenever you have a base of 10, you call it the common base. So instead of writing log base 10 of 100,000, you can just say log of 100,000 equal to 5. Let's do this example. 125 raised to the 1/3 power is equal to 5. Convert that into logarithmic form. If you want to recognize why is 125 raised to the 1/3 equal to 5? I thought when you take a number, you raise it to a power, it's supposed to be larger. Well, remember the rule that says x to the what? M over n, you have a fraction, is equal to, you can write it as a radical form as the nth root of x to the m. So what you have here is, let me write it on this side, 125 to the 1/3 power. 125 to the 1/3 is equal to, use this rule, you'll have the cubic root, so the 3 comes out here, of 125 raised to the 1st power, which is just 125. So ask yourself, what number times itself 3 times to give me 125? Well, that is 3. I'm sorry, that's 5. So you can say 125 to the 1/3 power is the same as the cube root of 5 cubed. So what do? This 3 with the radical cancel with this 3 with the exponent, which gives you 5. So it makes sense that 125 raised to the 1/3 equals to 5. So we proved the exponential portion. Now let's see how do we convert it into logarithmic form. We will write log. What's our base? Our base is 125. Let me use a different color. Log base 125 of, what's the answer, the argument? So log base 25 of 5 is equal to, use different color, the exponent is 1/3. So 125 to the 1/3 power equal to 5 can be written in logarithmic form as log base 125 of 5 equal to 1/3. So you need to note that if the base is higher than the argument, the exponent will be a fraction. Now it's your turn. Pause this video and do some of examples. Let's check your answers to see if you were correct. We had an exponential form, 7 squared equal to 49. So in logarithmic form, we'll say log base 7 of 49 equal to 2. We had 27 to the 1/3 equal to 3. Now notice the power is an exponent. So how do we write it in logarithmic form? We're going to say log base 27 of 3 is equal to 1/3. Remember what I stated. If the base, the exponent is a fraction, your answer in the exponential form will be less than the base. So it makes sense that 27 raised to the 1/3 equal to 3. And if you convert it into logarithmic form, you will say log base 27 of 3 is equal to 1/3. 10 cubed, 10 to the negative 3, is equal to 0 and 1,000th. Remember, the decimal place on the third part of the right side of the decimal is the thousandth with a th. So how do we convert that into logarithmic form? We recognize that the base is 10. That's what we call the common base. So we will say log of 1,000th with a th is equal to -3. I hope this video was helpful for you. Take some time, look back in your textbook to do more examples. In the next video, we will convert logarithmic form into exponential form.